So again, this is number 5 on the review. And so the difference between this one and number 3, okay, is if you look at this, these equations are not in slope-intercept form. These are actually in standard form, okay? But if we want to graph it, it usually helps to put it in slope-intercept form. You don't have to, but I like to. So I'm going to go ahead and take both of these equations and try and put them in slope-intercept form. And what I mean by that is I'm just going to try to get y by itself, okay? So I'm going to take this first equation. I'm going to do it in rojo. X minus 3y equals 6. All right. And so I'm trying to get y by itself, and so I need to move everything away from y. Okay. So again, the furthest thing away from y is x. So I'm going to move x by subtracting that from both sides. Okay. This goes away, and I get negative 3y. Okay. These we cannot combine because they're not like terms. Okay. This 6 does not have an x, and so we just get, you can get 6 minus x or negative x plus 6.
Babe, can you eliminate the x? The first x.
Why?
It's not eliminated. Okay.
Alright, and then I'm going to divide both sides by negative 3 to get rid of the negative 3. Okay. Alright, but remember you got to divide everything by negative 3. Alright, so this goes away. And we get y equals negative divided by negative is a positive. So really that's x over 3. 6 divided by negative 3 is negative 2. And remember, this is really like a 1 next to the x, so we can rewrite this as 1/3 times x. So I'm just going to rewrite this instead of x over 3 as 1/3 times x. And the reason I'm rewriting that is so that when I do my slope, I know what I'm rising and what I'm running. Okay, so I just did, this is the top equation. So I'm going to go ahead and do the second equation, and I'm going to do it in orange. Hopefully that'll be visible. Okay, and so let's do, actually I'm going to erase this. So it's here. Fortunately this is on video, so me erasing it's not a big deal. Now I forgot what I got for the solution. I think it was y equals, subtract x, 1/3 x minus 2. Okay, pretty sure that's what we got. Alright, so now we need to figure out what this one is. I'm going to do it in orange. So we got x plus y equals 2. Alright, this is actually one step. We need to move the x by subtracting x from both sides. This cancels, and I get y equals 2 minus x or negative x plus 2. And so that's y equals negative x plus 2. Alright. So all I've done so far is something we didn't have to do in number 3, is I went ahead and took 2 problems that were in standard form and put them in slope-intercept form. And now that I have them in slope-intercept form, I can go ahead and graph them. Okay. Again, I can graph them over here. We've done these before, but I like to just go ahead and put them in slope-intercept form. Okay. And so this time, I'm going to use brown and red. Okay. So I'm going to let this be my brown problem. I'm going to let this be my red problem. Okay. So look at this equation. I have negative 2 as my y-intercept. Okay. And the 1 tells me to go up 1. The 3 tells me to go right 3. Okay. Up 1, right 3. Up 1, right 3. 1, 2, 3. Okay. And again, remember, I could also make this negative 1 over negative 3 because the negative divided by negative is a positive. So it'd be down 1, left 3. Down 1, left 3. Again, this is not perfect because it's doing it not on a perfect graph. Alright, and so looking at this one here, okay, my y-intercept is positive 2. So my y-intercept is positive 2. And then I have a slope of negative 1 because it's like there's a negative 1 here. But remember, we need it as a fraction, so it's negative 1 over 1. Okay? Which tells me I need to go down 1, right 1. So down 1, right 1, down 1, right 1, down 1, right 1. I'm guessing that's about, I know that of course doesn't look right, but I think that's where that's supposed to be. Down 1, right 1. Okay. And so where do they intersect? All right. And they intersect, it looks like, at positive 3, negative 1. So let's check that. How do we check it? We plug it into the equations. Okay. And we can plug it into these equations, or we can plug it into these equations. So let's go ahead and plug it into the original equations just to make sure that we did this right. Because if we did something wrong here, then, you know, could mess the whole thing up. So but let's try the original problems. All right, so I'm going to take the first equation, which was x minus 3y equals 6. Okay, and I'm going to plug in 3 for x and negative 1 for y. So 3 for x, negative 1 for y. See, the 3 in parentheses just stays 3. Negative 3 times negative 1 is positive 3. And hopefully you know that 3 plus 3 does equal 6. All right, so it works out for the first one. So now we need to try the second one. Let's try it. So we have again x plus y equals 2. Plug in 3 for x. Plug in negative 1 for y. And 3 plus negative 1 does give me 2. Okay? So again, when I plug it in and it works for both, I know I got the right answer. Because remember, the solution to a system is what makes both of these equations true. So if I plug it in and it works for both, then I know it has to be the solution. Okay? That's it.